Hi, this is the first short video for multi-step equations 1 and 2. We're going to go over a couple of the equations in the first lesson. All right, this first question is Q on page 217. We see that we have two sets of brackets, so we know that the first thing we need to do is distribute. After we distribute, we're going to collect like terms. Our goal is to have the variable term on one side and the constants on the other side, so that we can go to step 3, which is isolate the variable. So let's do the distribution first. So we're going to distribute here. 4 times a is 4a, and 4 times negative 3 is negative 12, is equal to 3, and then we have a minus sign in front of the brackets. Remember that this is like a negative 1 being multiplied to each term. So that's going to switch the signs. So the a is going to become minus a, and the 5 is going to become negative 5 because we're multiplying it by negative 1. Now what I do is I worry about the variables next and then the constants, but you don't have to do it that way. You can move the constants around. And remember, you can move the variables to whichever side you want. My preference is to move the variable left, but you don't have to. I'm going to move this negative a over to the left, and that's the first thing I'm going to do. So I'm going to add a, because negative 1a plus 1a cancels them. And I'm going to make sure that I do this over on the left-hand side. So when I do that, I'm going to add them. 4a plus a is 5a minus 12 is equal to 3 minus 5. Now notice you have two constants that you can put together right away, or you can leave them as they are and move the other constant over. It's completely up to you. I'm going to leave them just because of space. And I'm going to focus on getting the 5a term by itself. So it's 5a minus 12, so I'm going to add 12, canceling, and I'm going to do that over here on the right. Now I know it looks funny, and that may not be how you want to do things, and that's totally okay. I'm going to rewrite it, 3 minus 5 plus 12, and I'm going to use same change opposite to help myself to see the integers as they are. So I'm going to put 3 and 12 together first. Those are positives. That makes 15. Plus a negative 5 is a positive 10. Again, you don't have to do it this way. If you have a way you prefer, the collecting the like term step can be different for each of us. But what's important to know is now when we get to the isolate the variable step, we will all come to the same conclusion. So I'm going to divide by 5 here to isolate a, and 10 divided by 5 is 2, so a is equal to 2. This next one is not in your workbook. It's very similar to question R in your workbook on page 217. So I just made this one up. You may want to try it, pause the video, and then watch the solution if you need. Remember your steps. You're going to distribute, you're going to need to collect like terms here, and isolate, and every question's a bit different, but definitely you're going to begin with the distributing step. All right, first step, we're going to distribute the 2 to both terms of the binomial. So this will be 5 is equal to 7 over 6x minus 10. And at this point, I'm going to show one way method and then another way. Okay, so we've got this x term down here in the denominator. We can't have that. We can't solve for x when it's down in a denominator. In order to get it up to a numerator position, we can multiply it and every other part of its binomial here. So we can multiply the entire thing by 6x minus 10, and that will take it out of the denominator, canceling it on the right-hand side, and that means that we're going to be multiplying the left-hand side by 6x minus 10. to show that a bit more nicely, it's now going to be 5 times 6x minus 10 is equal to 7. And now we're going to distribute again. So we're going to do 2 distributing steps before we can do any collecting of like terms. This will be 30x minus 50 is equal to 7. Now I can start to isolate the variable by moving my 50, the negative 50, we add 52 on both sides. And so I'm just going to write it over here. 30x is equal to 7 plus 50, which is 57. And now I can isolate x through division. Divide by 30, divide by 30. X is equal to 57 over 30. Now 57 is a bit of a strange number. Be careful here. Both the numerator and denominator are actually divisible by 3. 57 divided by 3 is 19, and 30 divided by 3 is 10. So if you're not sure, you can always punch in some numbers in your calculator to see if you can reduce the fraction. So that's the way that we showed in class, and that's a great way to do it. Another way to do this when you're at that stage after you've done your first distributing is where you have the 6x minus 10 in the denominator. Another way you can solve is by popping the 5 over 1, and you can cross multiply in order to get the 6x minus 10 out of the denominator. It's the exact same thing, so we're still going to multiply 5 times 6x minus 10 on one side is equal to 1 times 7 on the other side, which we know is just 7. And so we still need to do the distributing step and everything else, but just visually, that might help you to set it up kind of in a proportion. And we're still going to solve everything the same. We're still going to end up with 19 over 10. But it's just a little bit different right at that one stage after you've done the first distributing. So 2 ways, both coming to the same result, both because we are moving 6x minus 10 out of the denominator so that we can isolate x. In the next video, we'll check out clearing fractions. We'll do a few examples and look at how that can help us, even with questions in the multi-step equations 1 practice.